Hello and welcome to this session of the Advanced Java course. Today we will talk a little bit about optionals. Optionals are a class or a new feature of Java 8 that we've already used quite a lot. And I want to give you a quick introduction of what an optional actually is and how you can use it. So I've created an optional demo class here inside our demo project. It's not going to be part of that project, so this is just for showing our showcase project what we can do with an optional. Okay, so first of all, what is an optional? An optional in the functional world, an optional is a monad, and a monad is something that is an object that wraps a higher, or it takes a lower order object and makes it a higher order object by sort of wrapping it up and providing some extra features. Which means an optional of string, for example, it takes a string as the lower order type and makes it a higher order type. Now an optional was designed by the JDK guys, by Oracle, to provide non-null values, or to get rid of null values. That was their main purpose, which means it was designed to be a return value of functions. I've already talked about this a little bit in the previous video. You can also use it as parameters, but you're not supposed to by design. And by using some conventions naming being that you never provide null values as parameters, you could also use an optional to indicate that you want an optional at this place and you accept sort of null values. Okay, but let's take a look at the optionals itself. So how do I create an optional? Let's start with that. The optional class or the optional object provides you with three main factory methods. The first of it being optional empty. Here we go. An optional empty is an optional that does not carry a value. So this string that's wrapped inside this optional will not be there. Okay, another or two other factories, the other two, are off and off nullable. There are two different factories, which means if you call off, and you already know there is an off nullable, if you call off with a null value, well, this will throw an exception. IntelliJ also tells you that this can be a problem because this parameter in the factory method is annotated with not null. So if you want nullable values, you could use of nullable. Okay, passing null element to optional, that doesn't make any sense. Right. But imagine some other things here, like, I don't know, if you have a main method here, we could pass args of 0. And since we don't know if args of 0 is null or not, we would use of nullable. Okay, so now we have the string and we have an optional of string, which is a higher order object of string. It carries a string inside, but the value carried must not be there. What can we do now? An optional comes from the, or is in, its origin is in the functional world, and in the functional world you always have your three main operations. You have filter, map, reduce. Or yes, in the reduce system in Java, it's not implemented with the name reduce, but it is a reduction option, reduction method where I can take my functional element and transform it to something else. Okay, in this case, let's start out with a filter. Filter, it's not very exciting. It takes a predicate, which of course is a lambda expression returning a Boolean value. So we can do something here. So the string s is mapped to, I don't know, the length being greater than 5 or something like that. Okay, so we have an optional of string s1. Those are all, or this is the optional of the string, this op str, if the string we've passed has a length greater than 5. Okay, what else can we do? Let's carry on with s1. Filter map reduce were the things. Okay, I can map this string to something else. And the mapping function can be some arbitrary function, which means we could map it to the length itself, for example. Okay, if you take a look at what that is, okay, that's an optional of integer. Let's call this something else. slen. Okay, but we still have an optional. Okay, so we took the optional, we mapped it to the length of the string, and we got another optional, because if we call the map function, same thing applies to the filter function too. If you apply this map function to this optional string which does not carry a value, so the which is optional empty, it would return an optional empty. But if it doesn't, if it carries a value, it will return an optional of integer carrying the length of this integer. Okay, IntelliJ tells us that we can replace it by a method reference, and of course it's right. Doesn't make any difference if I pass the method here or if I write it down as a lambda expression using this arrow notation. Okay, now that we've used map, you also saw in some other code, you saw the FlatMap. Now what does FlatMap do? Okay, s1.flatMap, FlatMap. Let's go to the definition of FlatMap. It takes a function which has the domain of the optional and returns an optional of some other type. The other type is declared here. But it returns an optional. So if you take a look at the map function, it takes our string from inside this optional and maps it to, using this function, to an integer. Okay, so the FlatMap takes a function that doesn't return an integer, but it returns an optional of integer. Guess I didn't prepare an example here. Let's move over to the animal. Where did we use it? In the animal service, I think we used it. Right, here we used FlatMap on an optional. So what you can see here is we have a function that takes the optional of string. It's the same example, the same types. And this lambda expression here in the end, it returns an optional of animal. So we take the string and map it to an optional of animal. What FlatMap now does is it does not wrap it into an optional, which means we get returned this, or the element or the return value of this function, not of the mapping function. If you go back again here, the mapping function returns an optional of integer, even though the lambda itself returns an integer. The FlatMap does not return an optional of animal, but returns an optional of animal. That's what FlatMap would do, which is the second mapping function that we have here. Okay, now there are 3 reduce functions. If we take slen, the first reduce function is called or else. Or else is used to return another value, which means it returns the value held inside this s length. It's an integer. If this optional is empty, it will return this value we provided here. We can write the same thing with or else get. Takes a supplier. So we could write it same way as before. Yes, of course, this is excessive lambda usage, but I just want to showcase you what you can do here. And it's the same thing as above. Now, imagine or else get takes a supplier. The supplier is evaluated lazily, so only at the time that it's needed, which means you can construct new objects here. Really complicated objects, operations inside there, and calculations, for example. And the last one would be or else throw, which takes a supplier and supplier of throwable, which means we could throw in a runtime exception in this case. Okay, doesn't make any sense. Could also be replaced by a method reference. Yes, you're right. Let's do that. Runtime exception new, the same lambda expression as mapping the braces or parentheses to a new runtime exception. Okay, so those three operations are our reduce operations that the optional provides. Okay, now optional provides two more things that are interesting. Of course, let's take the first, the opt_str. We have an if, is present. I wanted to show you is present first. And this is for legacy code. So you could write something like this. What you would need then is a get. So you could ask this optional, do you carry a value? Is your value present? If it's true, yes, then give me that value. And then do something. So in some legacy code, you might need this if is present and the get. They always go together. If you call get without calling is present, IntelliJ will tell you so, that you didn't do that. And if the optional is empty and does not carry a value and you call get, it will throw an exception. So that's very nasty and does not have any advantages over using null values in the first place. Because remember, optionals were for replacing null values in returns. Okay, and the last thing that we have is the if present. So if present takes a consumer. Okay, now I could do something like, I could do operations inside here. So if the value is present, then do something with the value and, I don't know, print it to a stream, do something else with this value. I could use an closure here, for example, int I being 0, and so then I could assign I to s.length. Oh no, yeah. Now this is not effectively final, so I could not do that. But in the if present block, I could operate on this on this string, on this carried string, on the carry value inside this optional, if I would remember what were effectively final variables. Okay, that's all there is to know about optionals. Little comment on when to use them. You use optionals usually if you want to replace some values that could be null. So remember, you might always return optionals instead of a real null value, which makes your caller is now aware that he might or she might get a null value because you don't return just the null value but the optional. So that's always a good choice. If you think about returning null values, simply return an optional and you're safe. Using null values as parameters, that's a controversial point. If you have the convention that you don't pass null values at all, then you can use it. Otherwise, you can always take your parameter and wrap it up in an optional of nullable, as shown in this example up here. And that's all there is about optionals. Okay, thank you for watching and see you next time. Bye bye.